Look at this conveyor belt transporting a crate. Today, you will build and program this exact 3D factory simulation from scratch. In the next 6 minutes, we will download the software, map out the 3D environment, and wire the control logic to make it all run. You only need a Windows PC to do this. We don't even need external PLC programming software for today's build. Using the built-in logic tools means we can bypass the usual roadblocks of learning industrial automation and jump straight into hands-on practice. Step 1 is getting the software. Open your browser, search for the Factory I/O free trial, download the zip file, and run the installer. Once installed, open a new file. You will see a blank factory floor. Up top, there are 3 camera modes to choose from: orbit, fly, and first person. I recommend the first person camera. It feels the most natural. You hold the right mouse button to look around and use the arrow keys to walk forward, backward, left, and right. Take a moment to practice walking around the empty floor. Do not place any objects until you feel comfortable moving around. Moving confidently in this 3D space is the foundational skill you need before we can efficiently build out our simulation. Now let's bring in our hardware. Open the component list on the right. Search for a 2-meter belt conveyor, a box, and a button station, and drag them into your workspace. You will notice right away that everything drops completely flat on the floor. The button station is practically underground, which obviously isn't where a human operator would stand. To lift an object off the horizontal X and Y plane, we move it along the vertical Z axis using the V key. Select your button station, hold V, and drag your mouse up to raise it to a usable height. Mastering this vertical translation allows you to build realistic, ergonomically correct environments for your operators. With the physical pieces in place, go to the top menu and enable tags. This makes the digital labels for all your physical components visible in the 3D space. Let's test the hardware. Hover over the conveyor tag and click to manually force it on. You will hear the motor engage and watch the box move down the belt. Firmly. Now, before doing anything else, turn that tag back off. If you leave a component in the forced state, you create a manual override. Later, when you try to run your automated programming, it will completely fail because the manual force blocks the software logic. Manual testing is an important diagnostic step to prove the hardware actually works, but the environment must be strictly reset to 0 before we can start wiring the logic. Now for the brain of the operation. Go to the File menu, select Drivers, and open Control I/O. In the logic interface, drag in an SR flip-flop block. Take your Start button tag and connect it to the set pin. Then, connect your belt conveyor to the output. Our normally closed Stop button actively passes a 1 signal. If this reaches the flip-flop's reset pin, the system locks. Inserting a NOT gate inverts the 1 to 0, clearing it. Pressing Stop drops flow to 0, which inverts to 1, shutting down the conveyor. Real automation requires taking the physical, default electrical states of your hardware and correctly translating them into your digital logic. It is time for the final test. Click Run inside Control I/O, minimize the window, and hit the play button in your main Factory I/O workspace. Walk up to your operator station and press Start. The conveyor moves, and the indicator light on your button toggles from white to yellow while running. Control I/O is a perfect sandbox for learning these principles. Out on the actual factory floor, though, engineers program with a language called ladder logic. You have successfully built a working proof of concept. With this foundation in place, you are ready to step up and program actual Siemens PLCs in the next lesson.